as an Android developer here in Mindera, and I'm going to talk with you about Reactive Java with Android as a background, which means it can be a reference point to show some practical use cases, but I'm not going to give you an Android talk. It's mainly Reactive Java. So how many of you work today with Reactive Java? So one. So how many of you have read about it, know what it does? Okay, more three. This is the best I got today. But don't worry, this is not going to be an in-depth thing. It's just to give you an example of why you can use it, what are their potentials about reusing Reactive Java, and you probably can understand it all. So, you have here an interface which has three methods, getUser and toSetter, setName, setAge. And this is a pretty simple thing where you take a user manager, set its name, and then print the result of it. And this is single-threaded, so there's nothing special about it. You just set the name, and once you print the result, it will be what you are expecting. The name will be updated. But usually, you are not making applications that are only local, so you have to rely on a web service, so you have to send this update somewhere else. And if you do that, this no longer is a happy case, ping thing where everything works. You have asynchronous calls. And if you have asynchronous calls, they can be unreliable. So you have to account for that. And how do you account for that? You can make a runnable. So a runnable is just another interface, which has one method, which is run. And you can make the request to the web service, like set this username, and then when you give the response, you just run the method of runnable, and you update the UI, whatever you may be doing. But you are kind of being reactive in here, because you are only updating the UI once you have the response from the server. But you are not taking into account if it fails, if you don't have connection. A lot of stuff can happen, I'm sure you know about it, that a call can fail. And you can account for that as well. You can make a listener, which is just another interface, but has two methods. It has the success with the user object that is returned after you make the call. Probably from the server, it just feeds that to you, or not. But you have the failure as well. So you update the UI if you have a success. If you don't, there's no point in doing that. So if you receive a failure, you just say in a toast message, a snack bar, whatever you may be using, OK, I'm sorry, this operation didn't succeed. And you are already being kind of reactive, because you can be reactive without using Reactive Java. That's one thing I want to put out there. You can program in a reactive way without using any Reactive Java at all. It is a contract. You have to obey to a certain contract in order to be reactive. But Reactive Java just has a lot of methods and a lot of things that you can just use. And yeah, you do that, you apply that, easy. So, OK, you just set a name. So you set a name, and you have this block of code. Cool. Yeah, it's pretty simple. It doesn't have a big footprint of code in here. But yeah, I want to set the age as well. So I set the age. And it's starting to grow a lot. And if you have like 10 attributes that you want to update, you'll start to have a really big footprint of code, which can be avoided and can be accommodated by Reactive Java just because of a simple thing, which is Lambda expressions. But I'll talk with that just in a bit. Besides that, you also have state. State, some people advocate that state is like the source of all the problems. If you have state, like you are going to have problems, it's a mess. So functional programming tries to avoid that, but in an application you can't avoid to have state anywhere. You have to have state somewhere. So that's what happens in here. This is an example of Android. So you have an activity, which is one of the main blocks that you can have on an application. But imagine that this activity, not imagine, but it has a life cycle. So it can be created, it can be resumed, it can be stopped. There are a lot of states in there. And you just look just at this part where you have a text view, which is just a view on your UI. And you set the name to the remote call. And once you have a response of success, you set it in the text view. Cool. So you set that. But the activity has been thrown to background. Like the user just presses home button, it answers a phone call, and it's not there. All the context of the activity is being destroyed. So once you are trying to make that, because it's an asynchronous call, so it doesn't follow the main thread. It can be after the main thread has been destroyed. So it just throws an exception. It doesn't have a context. This thing just isn't there anymore. OK, but you can also account for that. You can make this. Is destroyed? Is being removed? Is not? OK, if it isn't, I can update it. Probably in a secure way, but yeah, I've made a check, so the next line in code probably is safe. Sometimes it isn't, but probably is. And also, the main thread. In Android, only the main thread can touch its views. So if you make an asynchronous call and you respond in that asynchronous call, this block won't be on the main thread. So it just crashes. And you can also try to avoid that, just making run on UI thread and run a block of code and do that. But you see, you just want to do this. And you are taking a lot of state, a lot of responsibility to just this call. So if you have 100 calls on all of your application, you have to accommodate all of that. Even if it is by an abstract layer, if it is whatever you want to do, but you have to accommodate for that. And state will, well, screw you up. And yeah, Lambdas. So Lambdas make our life easier, but it probably is a strange thing if you are not used to it at first. So you have an interface which has two generics in there. So it has a value and a mapped value. It has a function which receives a value and returns a mapped value. So generics is just, you can pass whatever you want, but you have to follow that rule. And yeah, this is more or less how we would map it. So it implements that. You have a list that you receive from a certain type of values, and you have a mapper which receives the value and returns the mapped value. And you go along that list and apply the map to that value, and then add it to the mapped, and then just return it. And well, OK, if you are going to actually make a concrete implementation of this, you have this. And you have like 6 lines of code just to make value times value. So I don't like this too much, so I prefer to use this, which is just one line, and you have everything in there. You have the return type, everything. You just have numbers. It takes a value from the numbers list and multiplies it, returns a list of that. Simple. You can apply that to a list of strings, to something that you can work out with this function in here. You define this. And yeah, it's a higher order. It's a pure function because it doesn't care. It just doesn't have any state whatsoever, what you see, what you get. And also it's generic, so you can apply it to a bunch of types of data without actually changing your definition of it. And this is pretty standard on Reactive. You have like an operator, but that operator can just work with a lot of stuff. You don't have to overload stuff, have a method just because it returns a list of strings, a list of integers. You just work with something like this. OK, so push and pull. So this is one of the key concepts of Reactive. Usually, you'll pull information. So you have like a list of strings. Create your list of strings. You have an iterator. The iterator is applied to every collection on Java. So if you have a collection of Java, you have an iterator. So you can do that. You can just take the iterator, run a while on it, and pull all the data. But that's the pull. I don't think you want to pull the data, because most applications are data-centric. Reactive is pretty much data-centric. It flows data. And you don't want to check like every 10 seconds, has this changed? OK, it isn't. Has this changed? OK, I will update the UI. You want that to be pushed to you. It's like your little push notification that just arrives at the right time, and you act upon it on the right time. So you don't have to pull something 5 seconds later than you should, and you just apply the logic that you want in a pretty simple way. It's just like this. You have a factory method, which is observable.from. And it takes, I think, different types. But one of them is that it has to be an iterator. So it's just every collection that you have in Java, you can create an observer from. It also takes subscribers, other types of stuff that I'll talk in just a little. And it's pretty simple. It's just to subscribe, method, that's it. So I've already talked a little about different layers of reactive. So you have mostly 3, I think are the most important ones. So you have the subject, which is what you are observing. So it's your source of data. It can be a list. I'm using lists a lot because it's simple to get on. But you can make a network call in there. Because when you are subscribing, you can, on subscribe method, you can override it. And since it is asynchronous, you can just make the network call, wait for it on that thread, so your main thread is just fine, and then start emitting the signals. And that's the source of data, but you have the observable, and the observable is what's handling that. So it is observing that data, and it's also passing it around, like with on next, on complete, on error, and I'll talk a little bit more about those, but just to keep in mind, on next is what you are getting for each string. On complete and on error, like name says, it's pretty simple, but they are terminal events. So for every flow, you need to have a terminal event, because if you don't, the observable will just be there, emitting stuff, or just having memory allocated to it, and eventually it will throw out of memory, because leaks are fun, and that's what they do. And yeah, so another thing is I encourage you to go to the documentation, because there are a lot of stuff in there, and probably you don't need to make a custom observable. You don't need to make a custom subject or whatever it is, because probably there's already that functionality in there. Maybe it's not exactly right what you want, but you can make a transformation and it just works, and it's simple for you. Because if you don't, and you want to take more control of what you are doing, you have to obey the contract that Reactive Java has. And if you don't, memory leaks again. So you have the interval, and the interval takes one parameter, which is the period and time unit. And this is just if you take 1 in seconds, it will emit once per second. If you take 3 seconds, it will emit 3 in 3 seconds. So it's pretty simple. I don't see an actual case to use this on our everyday life, but just to see that you can have like a timer just going and throwing, and you can piggyback stuff on this. So it is emitting once per second, but you can also add more stuff to it and can work with it if you have a timed thing going on. Also, there's the observable just. The just takes one type of data, like a class, a value, whatever it is, transforms that into an observable. And it just does 2 things. One is emitting that value, and the other one is just emitting one terminal event, which can be on complete or on error, but that's the 2 things it does, and sometimes it is useful, like you have a non-error, and you want to make some default in it, and you handle that, and just throw the just, or empty. This one just doesn't send any data, it just throws a terminal event. So, okay, those events. The observer. The observer is the dummy part of the entire thing. It lives near your UI. It can be your presenter, your fragment, your views. It lives more on the UI side. So it doesn't care at all if you are on the main thread, if you are not. That should be handled upstream. So you have the flows emitting data, you have the observables, all the transformations you can have, and in the end you have the observers. Everything you need to do, just do it upstream, not on the bottom of it. So you just have this. You have the on next, where you can update your UI, on complete, on error, to do whatever you want. But this is the dummy part. And it's one of the big selling points for me in Reactive Java and using it instead of another traditional thing, because you can make small changes using Lambda expressions, like in 5 lines of code, and it just transforms completely the data that you are receiving and can do a lot of stuff. And yeah, it's nothing special. You just have the observer and implement those, another list, subscribe. And it will work. It will just emit data, and you have just transformed the list, standard list, into an observable. So yeah, transformations. So what I've been talking about is all these key players, and you have one thing, which is you can transform your observables. So you have your flow of data, which is coming here. And by the way, if you are going to read upon Reactive Java marble diagrams is the thing that will pop in your face all the time, because it's simple to get the general feeling and logic of what it actually does, and it's pretty simple. You just have a flow of data in here, you have all the data being signaled to this, which is the transformation, and then you receive this on the observer. And this is one terminal event. This bar is uncompleted. If it was a cross, it was on error, just to let you know. And another thing that I encourage you to do is don't use these transformations if you don't know what they are doing, because map seems pretty simple. Like you can use the other case that you have where you multiply a value by another. You can just have that in here, and you have 2 map 4. It's pretty simple. But you have to understand it, because what it does is it takes a value. It's only one observable in the entire thing. It takes one value, maps it to something else, and returns that same type in the end. It can be different, but it's always a value. It's only one observable. And the reason I'm saying this is because you can, well, flat map seems pretty cool, so I'm just using it, and it's pretty much the same thing. I have the flow in here, flat map it, and then have this in here. Well, maybe they are interleaved and mixed together in terms of order, but pretty much the rest is the same, but it isn't. You have a signal in there, and for every signal, you are going to create an observable. So it's not just one. The part you are seeing, it is one. It is in here. But in here, you have multiple observables, and you can take advantage of that, but most importantly, you need to account for that, because you can have unexpected behaviors. So what it does is for every single item in there, it creates an observable, and you can have a bunch of them that are handled internally by flat map and the observable itself, and in the end, they just flat it to one observable. So what you are actually consuming is just one observable, which is cool, and you can make a lot of stuff. And the reason why this is interleaved is exactly because of that. Because if you have one observable, they start emitting data. So it doesn't guarantee that the order that is being received in there is the same order in here, because they are asynchronous. They are emitting on their way. They can take a little too long to make an operation, so they fall a little back behind, and you start getting this, which can bite you in the ass if you're expecting the same type of transformations in that order up there. So just to be careful, another classic one is if you have that thing in here, and you just make 2 lists. Okay, I don't want to receive like 20 items. I want to receive one item that has 20 items in there. 2 list doesn't emit anything. You have to handle that by yourself. And some people just do a 2 list and wait for it. Nothing happens. And yeah, you have concat. Concat. In here, you have 2 observables, 2 flows of data. You have that one and this one. And what it does is exactly that. It concats all the flows of data. But once one is completed, it will start emitting the other one. So this one actually guarantees the order that is being transmitted in there. But if you, well, maybe use a merge. You read it, okay, merge. It probably does what I'm thinking. No. So in here, it will just emit stuff. And one important thing to retain from this is you have your terminal event in here. So imagine that you have like 8 data sources and you have legacy code. And yeah, I'll just group all of them in one observable and treat it in one point. And that will be awesome, because I'll just have to maintain this. I don't have to maintain all the 8 data sources. But yeah, but if you do that and one of them fails, you see what happens. Everything else fails. And if you don't expect that, yeah, you have to make changes. That's why there's merge delay error, which will take this error just to here. So it will say, yeah, this one failed, but I don't care about it. This one is still emitting. I don't have a terminal event, so I'll continue emitting this. And in the end, it will emit the error, and you can handle it the way you want. And yeah, that's pretty much it. I also want to give you a few extra things, which is this was mainly focused on Reactive Java 1, because Reactive Java 2 just came out like 2 months ago. We didn't have time to do any migration yet, and migrations are fun. But yeah, everything, I think I was careful enough not to show anything that couldn't be applied to Reactive Java 2. So all the concepts that I talked about are applied to the Reactive Java 2, although it was built from the ground up, from scratch. because the guys from Reactive 1 didn't took into account one simple thing, which is what if the observable is emitting data in a rate that's so high that the observer can't handle it. So that's a good one, because imagine you are just dribbling on your phone and all that data, all that coordinates or colors or whatever you are sending to your observer through your flow, it's just too fast. The user is just going too fast. You can't just say to the user, oh, stop like a second in there. And yeah, continue drawing. So what it does is exactly that. It doesn't interfere with the input that the user has, but it throttles. So it can actually say, okay, calm down a bit. Let me handle all that data and then continue providing it. And that's one of the big things. So you have observable, which doesn't take into account backpressure, but you have flowable, which is pretty much the same, but you have to define like a strategy. It's like a cache strategy. You define a backpressure strategy, and it's taken care for you. So yeah, I think it's pretty much it. This was my third talk ever. The first one was like an hour before. The second one was like 30 minutes ago. This is the third one. So I'm glad it was in here in Mindera, and I hope you all liked it. Okay, perguntas?
Any questions?
Just one. I didn't receive a question the entire day. Please, just one. Yeah, that guy. No, that guy, not that guy.
I'm not really going to ask something about Reactive Java. I just want to know if here in Mindera you always are looking for migrating your software to something new. Because, like you said, you use Reactive Java, it's something new, basically. I don't know if it has 2 years. If you have applications on the market like 4 years ago, are you going to migrate it?
Yeah, at least from my personal experience, we do migrations a lot. Because imagine you have retrofit 1 and you have retrofit 2, which is a pretty standard way to integrate your application with your backend. This is a little bit comical, but we did that migration and we found one problem, which was we were crashing the server. It was throwing a 500 internal server error because retrofit was making the call so fast that the server couldn't handle it because it wasn't stateless. That's a given. But yeah, don't migrate just for the fun. Well, if you can migrate just for the fun of it and be on the latest thing and all of that. But usually when are the major versions updates of it, like Reactive Java 2, it's built from the ground. It doesn't have anything from Reactive 1. It's a fresh new start. Probably they will take a lot of history and errors they make in the past and try to improve that a lot. And so when I have time and if I instantly regret it because I just, okay, I'm going to migrate this. And yeah, this will take a lot and I'm going to kill myself. But in the end, when you do it, the things that you gain from it, yeah, it's way better and you are glad that you did it in the end.
You've been working with Reactive for a bit of time. So what were your biggest pains and the biggest cases where you thought, I'm going to kill myself for using this?
Yeah, so as you could see, it looks like it has a lot of magic going around. Like you have 15 or 50 asynchronous calls all going wild and you can't really follow it. So what I got was already a base that was set up. And you need to go to the base and all that abstract layer to know what is going on. Because if you are new to Reactive and you are just handed a framework that is handling all of that, you can't follow the logic. You can go to the observable, but the synchronous calls, if you're using libraries, if it is going to that fragment, if it isn't, if it's using functional interfaces, if it isn't, it's a lot of things that you have to take some time and that let the thing sink in. And but yeah, it's not easy to use Reactive. It takes a lot of effort. You have to read a lot of documentation and kind of be, well, you have to just give it time. But the other thing is, so at least for Android, you have memory leaks. And it's a huge problem. And like I didn't demonstrate the unsubscribe part of it, but once you subscribe, if the data source hasn't terminated yet, you have to unsubscribe it. You have to account for all that is the life cycle, whether it is an activity, a fragment. You kind of have to take all those references and see, okay, if this one already terminated, you signal it to whatever layer is handling that, and subscribe your observer and free all the memory that you can. Because you can have, you shouldn't, but you can have things on those functions, Lambda functions that you had in there, which can have hard references to your activity, to the context that you are using in the fragment, and it isn't going away. If it's in there in that listener, it's not going away. And that's one of the hardest things to do when you take Android. I believe iOS is pretty much the same. Just be careful with memory leaks and all of that. It isn't for free. Definitely it isn't for free. Just one more. One more. Yeah. Okay.